you will go completely wrong. It has to use curved spaces, not flat spaces. At the beginning of 20th century, I think it is 2004 or so, the great mathematician Poincaré looked at this problem of Euclidean geometry and non-Euclidean geometries. They were all equally rational, equally good, but the conclusions were different. The theorems were very different. So Poincaré said, okay, now that we have these different geometries, which geometry applies to our world? The world that we live in, is it Euclidean or non-Euclidean? And Poincaré said, obviously, our world is Euclidean. Just a few years later, Einstein showed that the world that we live in is not a Euclidean world, it's a non-Euclidean world. Poincaré was wrong. Poincaré was not wrong about mathematics. He was wrong about the modeling of this real world in terms of different kinds of mathematics. So the assumption that this world is Euclidean was wrong. It turned out to be this world is not Euclidean, it is Riemannian. Very good. Okay, so let me go back now. Definitions create objects. Postulates create the world in which these objects exist, like spherical world versus flat world. Axioms are still higher, more abstract about conditions that apply to any world. Axioms like if A is equal to B and B is equal to C, then A is equal to C. Or if also if A is equal to B and A is equal to C, then B is equal to C. Those are the statements that apply to any possible world, not just one particular world, whereas the kinds of postulates that Euclid assumed apply to the world of geometry, not the world of algebra and other kinds of things. These things, the axioms, which are not postulates, apply to other things as well. Apply to not only to Euclidean geometry, but also topology, graph theory, and so on and so on. Nowadays, people do not distinguish between axioms and postulates. But it's a good idea to keep that at the back of your mind. So you have to create three different kinds of grounds. One, define objects. Then define the world in which these objects inhabit. Now define the statements which are true in all worlds. Three levels of abstraction. Now you derive the consequences, the theorems. Okay. So what I've described to you is a way of doing research on the basis of definitions, postulates, and axioms, and then the logical consequences. And the logical consequences will be different depending upon what you choose in any of these cases. Change your definition, the theorem changes. Change your postulate, the theorem changes. Change your axioms, the theorems change. What I want to do next is to use the same way of investigation, with slight difference, in science as well. Okay?
You showed that example of that line on paper and then
okay, sir, so like you told that you take a paper and then you draw a line, and then this is if you curve this thing, then the distance between 2 points is that shortest distance.
Yeah, I have to fix the definition slightly.
So what if I go on till where at the coincide exactly the 2 points?
so the
Like
two
Yeah.
points actually coincide.
Yeah, that's what happens in a spherical geometry, right?
Yes, is that
The great circle, so-called great circle, is a straight line.
no? But if the 2 points actually coincide, I mean those were the 2 points you were talking about initially, and
Yeah.
the
I know,
smallest distance between the 2 points is 0 now.
I know what you are driving at.
yeah.
So let me. Okay, I'm going to draw a straight line like this. So the white thing is the space. And this is an object in the space. And this white thingy is a flat space. Now, what I said was if I do this, what looks like a circle is a straight line. Now, how do I get the idea that this is a straight line? Because suppose I say this is A and this is B, right? This is the shortest path. This one is outside. Now, if I put them together, this is the shortest path, but is this the shortest path? Right? So I need to define shortest path or straight line in a slightly different way to get that right, such that the definition applies to both Euclidean geometry and non-Euclidean geometries. How do you do that? Here is the way of doing it. I wasn't planning to go through this technical problem. Okay, so if you have, one is given 2 points A and B, okay, the shortest path is a straight line. And then you have to add another clause to it, namely, if you have a line such that if AC is a straight line and BD is a straight line such that this is part of both, then this is a straight line. That will take care of the problem that I mentioned, this one. Because you divide it into more sections and say, you prove that this is a straight line, this is a straight line, so the totality is a straight line. So the so-called great circle now is a straight line. Otherwise, you have between two poles that semicircle is a straight line, but not the total circle. But given this idea of straight line, the great circle is also a straight line. So the black hole, light travels in a straight line when it comes back to itself. Right? This is part of physics. So the only way of getting physics match mathematics is to define it that way. So I told you earlier that you didn't know what a straight line was, right? This is a way of showing you that you didn't actually know. And now, of course, if I ask you, do you know what a straight line is? Your answer would be probably, I'm very confused. That's a good thing. See, when you're completely certain and you think you know everything, then there is a problem. But when you say, I know certain things, but the rest of the stuff I'm very confused, then that is the beginning of research. Right? If you already know stuff, why should you do research? So I took a course when I was teaching at Stanford. I had a problem with language development. I didn't quite understand language development, which is one of my areas that I was interested in. I still am. Because I didn't understand language development, I decided, okay, I can find out from biological development. So there was somebody teaching a course on biological development, the next building. So I called him and said, hey, can I attend your course? Is that all right? He said, yeah, sure, fine. So this was a large course with something like 300 students or 400 students. There were a battery of teaching assistants, something like 8 teaching assistants. So he left all the tutorials to the TAs, and the division of labor was, there was a fat textbook, and he said, I want all of you to read the textbook, I'll give you quizzes, and my TAs will help you with the textbook. I looked at the textbook, I bought the textbook, I looked at it and said, there is no way I'm going to read this. It's impossible. Anyway, I wasn't going to take the exams and stuff like that in the quizzes, class tests, so it didn't bother. His lecture, he said, I'm not going to talk about the stuff in the textbook. That I want you to learn anyway. But I'm not going to lecture to you on that. Lecture was a lecture series on what they didn't know. What the current state of biological development didn't know, but would like to find out. So in every class he began by saying, here is something extremely interesting, we have no idea, we don't know. Next class, he will begin with another mystery. This was one of the most beautiful courses I have attended because it was a course of mysteries, a course of ignorances, not a course of knowledge. Of course, the knowledge was there in the textbook, he just didn't care. He said, that is left to the TAs. Why should I talk to you about what is there in the textbook? You find out. So I didn't learn much from I didn't bother to learn the details of the textbook. I learned about the mysteries. And that is where research begins. When you come to realize what it is that we don't know, what it is that the whole academia doesn't know, then you can do research. But if you are told only about what we know, what can you do with it? It's the boring stuff. So I take it that my responsibility is to make you aware of our ignorance rather than our knowledge. And if you know what ignorance is, then you can do research. If you have knowledge, no research is possible. So it's much more interesting to look at the ignorances. Okay, I will continue with this, but now switch to the science part, because as I said, my interest is neither science nor math, but the ways of investigating and seeing the parallels between different kinds of inquiry. That's what I'm interested in. So I'll transfer these words like axioms, postulates, and so on, to science and see what happens. So I'll change the word theorem to prediction. Change the word axioms and postulates to laws. But the rest is the same, with some slight differences. Okay, in the meantime, if you have questions, do ask questions, raise questions in the discussion forum. Okay, the whole of today's class was because of a question that appeared in the discussion forum. Okay, you can find out what the question is. You can now go back. Those who have not joined, you should join this. The discussion forum is where most of the action takes place. The class stuff is a minor consequence of the discussion forum discussions. But I heard you say something about the email addresses. Those are my email addresses. You can call me sir. I will not. Bye again. You can call me Mohan. You can call me Mohan. You can call me whatever. No sir. No professor. What did you call me? Okay. Okay. If you can manage to convince the rest of the class to move to some other time, I will move to Tuesday. Yeah. Friday, I could be traveling, so I may have to cancel. Fridays and Mondays, I think. I would rather take Thursdays, or I can take some more something else. Yeah, okay, yeah, thanks.